So what were some of the ideas about iteration? What is iteration? And why are we talking? Well, we'll talk about why. What is it? Let's talk about that first. What are we talking about with iteration and fractions? It doesn't have to be the definition. That's not what I'm looking for. Just ideas. Yeah.
You're like given a part and you gotta make the whole.
Yeah, right? So it's like repeated copies, right? And specifically, what copies am I repeating with fractions? What part? The unit, yes. Yeah. So iteration in this sense is just repeated copies of a unit fraction, right? So if this is 1/3, I can repeat that. I can make a connected copy. And I can make any fraction that I want to. So this fraction would be 4 copies of 1/3, right? Anything else that you talked about? Iteration is not specific to fractions, right? Iteration itself means repeated. So in our context, we're talking about repeating unit fractions. Iteration is a very mathematical topic, but it comes up in things. Yeah. Or maybe not. It comes up in everyday life, right? If you've ever done any design thinking, they talk about iteration, and you have to come back to the idea and come back to the idea and come back and repeat it. But in our context, we're really talking about iterating a unit fraction. All right, so the second question I have for you to talk about with your partner, that's not the right computer, is this. Why is iteration important to fractional understanding? So by iterating that part of 1/3 to create 4/3, what are students thinking about in relation to fractions? Why did I say that this is an experience in the very first session? I said kids need to have experience breaking things and actually making the equal parts, but they also need experience with iteration, which is building up fractions from the unit. Why? What is it that they're thinking about? See if you can remember some of those ideas. Go. Oh, and partner A, B, same thing, but switch. Awesome. In the back, can you guys share something that you talked about? Why do you think iteration would be important? What did you hear something in your group say? Or maybe you heard another group say something.
Well, taking the unit fraction and then building it up repeatedly, you start to see the different whole that they can combine to make.
Okay, so attention to the whole. Which we know in fractions, right, is a big challenge for kids. And really, I'm going to, right, call that the whole unit. Okay? What else? Somebody add on or give me something else?
And to piggyback, probably, that the whole can be different sizes.
Yeah. So, I think I was going for something else. I'm going to put something. So the whole can be different sizes. I was going to add on to that also multiple ways to interpret a whole. And we might get that later on today. Anything else? Why iteration? We're going to add to this as we talk today, and see why this is such a foundational concept for kids that they do not have any experience with in their materials. And so go ahead and thank your partners. Head back to your seats. So during this time, we're going to spend the entire chunk talking about the iterative fraction scheme. And within that, we're going to talk about really 2 experiences that we want kids to have. One is beyond the whole, and one is sharing multiples. This is posted, this PowerPoint or Google slide is posted in your classroom. So if you don't want to write it down, I also have notes in the notes section. So if you were like, oh, she wrote something down about that, it's probably in the notes section for you. So that if you are that person who, at least for me, if I'm writing, I'm not actually really listening. I'm just writing. I can't listen and write at the same time. So if that's the way you process, I'm just going to invite you to do that. But if not, this is totally available to you. So beyond the whole and sharing multiple items as experiences that promote the iterative fraction scheme. And the iterative fraction scheme is the foundation of all fractional computation for kids understanding that conceptually. Okay? And you'll know what that is. And then we'll take some time to think about our curriculum materials the next time so that we can dive into some resources, and then you'll take time for your implementation plan today. So I guess for me, instead of standing up and finding another person, I'm curious, because I wasn't here at the last session. My two colleagues, thank you for welcoming Carrie and Danielle. I'm interested to hear what the most important point was of the last session for you. So if you could just quickly share with someone around you, and then I'm just going to take a little bit of feedback to hear what was it that you took away from the last session. So anybody want to share? I'll take at least 3 most important points, and that will kind of help us as we move in today. What were you taking from the last session? Yeah.
So the first thing was partitioning was exhausting the whole.
Yeah, so using up the whole thing. How many people have seen the kids like, oh, I'm going to give that piece to my dog? Yep, yeah. I'm good with that. It's all right.
So the one that was in the video that she was really having a very difficult time dividing.
Yeah.
And kept trying, and she just wasn't getting it.
Yeah. Good. So exhausting the whole is really important. Other. 2 more.
Students see fractions as a part and not as a whole number.
Yeah, so they really do it as kind of separate pieces, right? So they see the numerator, they see the denominator. They can count those numerators, they can count those denominators. It actually ends up becoming a counting activity for them most often, right? So 2 parts shaded, 4 parts unshaded, or, so I have 2 6 now. Other points, at least 1 more.
I like the game.
Good. Was there a game in particular or several games that you found beneficial with your students?
I only done the one with the unequal parts.
Okay.
And I liked that one a lot. It made the kids think, but it was also really quick and easy.
Good. Awesome. Yeah.
I use the ones with the Kuznets rods.
Yeah.
Because our curriculum is all based on surface fractions.
Yes.
And everything in our curriculum.
What curriculum?
Everyday math.
Oh, okay. Yeah.
So instead, when we were introducing when we were doing equivalent fractions, and they were having them use their circle, and I did not let my kids cut out these circle fractions in the back of the book, so we pulled out the Kuznets rods and we did that.
Nice.
And it was super. It's just gone from really easy from that point on.
Good. So that linear model was really helpful for them to conceptualize.
No, anytime we make a fraction, we make a square or rectangle. We don't use circles, so we make hand pizzas instead of.
Yeah. Brownies. Sure. I'm always cutting up bubble tape. I don't know why, but that seems to be something that 5th graders, I've been working with 5th graders a lot. So they love those bubble tape things, that extend forever, like a foot of bubble gum. Oh. So I'm always like, this is your foot of bubble gum. I don't know. That's just the example I keep using. Awesome. Anything else? Okay. So with the iterative fraction scheme, we are going to do some of the math together. I don't know if I have enough copies. I'm hoping. This handout, this may or may not be easy for you. I can tell you that the first time I did this, I was like, what? This is weird. It really took me a while to kind of wrap my mind around this. So your table, you can share one maybe? You guys are shorted one, you can share. Thank you. And you can just grab a piece of paper too and just draw your own bar. So if you have a blank piece of paper, I really encourage you to do that and do this for yourself. It's really helpful to pay attention to what you're thinking about. So even though you have the question, these activities, and I think I've said this before, come directly from this book. So I didn't create these activities. They come right from this book, and this is really the research base that we're using. And you're welcome to take pictures of that later or ask me about that. So this is your granola bar. There is another granola bar. That is 7/5 of our granola bar. Can you draw the other granola bar? And it really should be, sorry, this should be your granola bar, not our. I left out the Y there. So add a Y. So this is your granola bar. There's another granola bar that is 7/5 of your granola bar. Can you draw that one? Draw it below it, please. Feel free to mark up the other one, but draw the new bar separate. I'm going to, we don't have a document camera, so I'm just going to sketch a couple pictures that I saw. I would usually have you bring up your own drawing. So I saw this. I saw this. I'm going to look at those two drawings. What I want you to talk about with your partners is, what do you think? Let's call this drawing A and drawing B. And it's okay if your drawing looks different. We're just going to talk about these drawings for right now. So there are some other drawings out there. So we're not saying that this is the only two drawings. But I want you to think about these two drawings. What were they thinking about in relation to your granola bar and the new granola bar? What do you think they were thinking about? Talk about that at your tables, or maybe your drawing looked the same and you can explain what you were thinking. Go. All right. Is there someone who thinks that they could give insight into A or B? Why do you think, and maybe choose one that you didn't personally draw. What do you think they were thinking about in one of these drawings? Yeah, please, go.
I part A.
Yep.
The big rectangle, the unsplit is the whole.
Okay, so that's your granola bar. So this is a whole.
That's the whole granola bar, and then they're envisioning it split up into fifths, and so the two extra fifths are just attached to the end of it.
Oh, so they're thinking that I need to add 2 fifths to a whole. So one whole granola bar, and then a fifth and a fifth to the end of it, right? Yes, I'm seeing some. Why are you saying yes? Definitely. Yeah.
Well, because the whole is getting split up in 5 fifths, so we're partition that.
So are you talking about A or B? You don't think they're different?
They're different either.
Okay.
I know the pictures are different, but I don't want to.
Okay, keep going.
I don't want a video saying I don't think they're different.
So I'm gonna try and write. So you said something about you take the whole and make it 5 fifths.
Yep.
Okay.
We partition that.
Okay.
Now we iterated 2 more fifths on it.
And then 2 more fifths. So it seems like you think. Are all people agreeing 2 fifths on the end of it? 2 fifths seems logical. Why 2? 2 more than 5 fifths. Okay, so we kind of have these two pictures. Now I'm going to pick on you just a little bit because you said the pictures you think are the same. You know that they're different, but you're saying they're really the same. Can you say more about that?
Well, I just think that when I looked at that, the person who thinks the whole is a 1 is already assuming that 5 fifths and 1 whole is the same thing.
So they were already
They just made
kind of thinking that and that were similar.
Well, that's 5 fifths.
So this was the 1 here. Okay. And then they also added just 2 more fifths onto there. Yeah.
I was going to say that I was one that had to partition.
Yeah.
And the reason that I partitioned is because I needed to know how big those 1 fifths were, so I could iterate the other 2
Nice
fifths
use of that word.
in this with the same sizes.
So it wasn't that you didn't understand that 1 and 5 fifths were the same.
Right.
You were thinking about size.
I needed to know how big my pieces were.
How big is this so that I can put that on the end?
Yeah, so I had to divide first. So I
Okay.
could keep it going.
Got it. What do other people think about that? Yeah.
So I did the same kind of thing after I thought of one thing differently before. So I was stuck on, okay, well, this is really confusing reading this.
Yeah.
So I had to do the whole 7 fifths. I circled the word of my
Oh.
granola bar. And so I did 7 fifths times 1 first to make sure that I knew 7 fifths. And then I partitioned into fifths, found my size, and then iterated my 7 fifths.
7 fifths. So that's interesting because you weren't actually thinking about this. You were thinking, like, I have to take 1/5 7 times, right? Like, repeat it 7 times to get 7/5. I want you to take a look at those 3 equations there, and I want you to think about which equation matches your thinking now. Even if so I'm also going to give you permission to go, oh, I wish I had thought that. Now I want to think that, so go ahead and think that now. So which one of these is most closely matching your thinking right now? And go ahead and share that at your tables. This conversation goes way faster, right? With a 3rd grade or a 4th grade classroom, actually in 4th grade, this would be appropriate. This would not be appropriate in 3rd grade. The 3rd grade does not ask for equations, even though your materials might have them. It's not what the 3rd grade standards say. This is the 4th grade. This activity matches 3rd and 4th grade standards. So much longer of a process with students, right? So I'm going to kind of step outside and say I want to facilitate how I would facilitate with students, right? And so what did I do? What was I trying to draw attention to? Yes, I wanted the idea of the size to come up. That was really important. I wanted you to think about, I have to have a piece. I have to know what size it is, and I'm going to repeat that piece. That was my only goal for this, right? And then this is my note sheet right here that I wanted to write some equations for your thinking because I knew someone was going to say something like this. So I was prepared with an equation if you said that. I was also prepared for this. It wasn't necessary to have this, but I was prepared and I thought, yep, I could also write this as multiplication. 7 groups of 1/5. So I want to write that if someone says that. So I'm thinking about what's the math that I can attach to their ideas when they draw it. So a question came up, would I have kids label? No, I wouldn't. I want to make this activity accessible to all. But notice something. I chose the drawings that we talked about. And I'm gonna put out a claim that sometimes our discussions are not focused in our classrooms because we cold call on kids. And when I mean cold call, we say, who has an idea? And you raise your hand and you have no idea what idea is coming out and whether it's mathematically worth pursuing. It doesn't mean engagement. And I know there's a lot of rubrics out there. You were all engaged in this task and talking at your tables, and you had an opportunity to think on your own. But I have a mathematical goal that I'm going to get to in my class, and so I'm looking for the drawings I want to talk about. I'm not looking for the drawings that mathematically are correct, but I'm not interested in pursuing. So one of the drawings that's mathematically correct is to draw the whole and the 2/5 disconnected. I don't want to talk about that drawing because I'm trying to get you to think about extending the whole. That was my mathematical goal. I wanted you to put 2/5 onto the end. Other people had that drawing. Great. But notice when I put those 2 drawings up, I said, these are the 2 drawings. There's lots of drawings out there. This is not the only right drawing. These are the 2 we're going to talk about because it's going to further my mathematical goal. So I'm going to push on the idea that we have to hear every single student's idea and put it on the board. We hear students' ideas in their groups, and then we build on the ones that are going to take us mathematically someplace. And sometimes we get those ideas from students that you're not expecting, right? So I'm really cautious to make sure I'm not getting the ideas from the same student every time. I might even have a partial idea that I put up, like, oh, someone started to do this. What do you guys think about this? Could we add on to this idea? Could we finish this idea? So I just want you to know that there were many drawings out there that were correct mathematically. But I was pursuing a specific drawing today. I would have talked about just this one. I would have talked about just this one. If this one came up, I would have asked, where's my granola bar? Or where's your granola bar? I can't see it in that picture. And we would have identified it. But it so happened that both of these drawings came up so we could make that comparison, right? So I'm prepared with questions mathematically that I want to push students in. Yes, it's kind of manipulation because I know what ideas I want to come out, but they're exploring the content, right? And I'm just connecting the mathematics to it. One of the best researchers that I follow is Karen Karp. She is a special ed mathematics researcher. And she talks about explicit instruction. We think of explicit instruction as direct instruction. Like I say, you do, right? We have 50 years of math instruction that looks like that says we're not successful at that. We have lots of national data to say that we're not successful at that model. She says explicit instruction in mathematics is the students do, and we explicitly connect the math ideas to it. They're doing the math. You guys were doing the fractions. Students will break up their fractions here. They'll equally share things. You connect the notation. And you bring it up. So it's not, okay, so today we're going to learn how to write fractions and add fractions. And this is what you do. This is the notation. The notation gets learned with the concept. And so I'm always thinking, how do I want them to write this mathematically? And what are they going to say? And how can I put those things together? Okay? All right, so we're going to try the next one. You're not going to like this one. This one's uncomfortable. Maybe you'll like it. I was uncomfortable with this one. So this is your granola bar. I'm going to put it in context for you. You work for a granola bar company. So this is your original granola bar. It's 9/7 of the granola bar you want to produce. That granola bar is 9/7 the size of a granola bar you want to make. Draw me that new granola bar that you want to make. That's 9/7 the size. This one is 9/7 the size of the granola bar I want to make.
Well, I know that, but I'm thinking the other bar.
You want to draw the other bar. So what is the other bar? Go ahead and talk about that with your partner. Everyone drew the same picture, which is very interesting. And I even saw this. So this is your granola bar. This is the new granola bar, I believe is what your drawings represent.
Like that opposite, but that's all right.
So why is the new bar smaller? Talk at your tables about that. Why is the new bar smaller? That's weird. Go.
Right. Because we only needed 7 of the 7. Yeah, was the XL, so we had to get the 2 sets on it.
You're overthinking it.
So yeah, ours was 2 7s.
All right. I'm going to pretend that there was some people in this class, because you will definitely have students who draw a bigger bar, right? Not a smaller bar. So I'm going to pretend that there were some people that drew a bigger bar. So I want someone to convince that group that the bar should have been smaller. Who thinks that they could produce an argument for why it should be smaller? Yeah.
When I look at this bar as 9/7 of another granola bar, I want to think that it's the new granola bar has to be the whole. So 9/7 of the whole of the new granola bar would then make it smaller because 9/7 is more than one whole. So I need to figure out, I need to take that and take the new one.
Who thinks I can say that in their own words? Could you repeat what she said? Yeah.
So we're looking at 2 different wholes. The one that we see up there is a whole granola bar, but when we're making a new granola bar with a different size, it's going to be a different whole. So this one up here has to be bigger than our new whole because 9/7 is bigger than one whole.
So I'm going to add the word new whole. So 9/7 is bigger than our new whole. And this is our new whole right here. And how big is our new whole? 7/7. And I saw some people even have kind of a divider there, like that. Okay. Yeah.
Can I bring this to a different level for a second? So 9/7 times something needs to equal 1. So we have to...
You really like those O's and...
So then we have to do the reciprocal, which is 7/9. So you're making it 7. That's not how I thought of it originally, but then I just realized it with my picture. It's 7/9 of the original.
To get this.
To get that.
Okay.
Okay. Sorry.
It's all right.
Not elementary, but middle school.
So, now where I want to go, here's a teacher move, right? You're always going to have students in your class who are thinking differently about that. Wow, that's really interesting. I wonder if that works for all of them. We'll maybe talk about that another time. And you move on. It's okay not to get off track. My goal for you is this, 9/7 of the new whole. And I really want to think about 7/7 and another 2/7, right? Being that 9/7, so this has to be the whole right there. Okay? So I'm not going to get sidetracked from my goal, but I'm going to acknowledge that's a really important mathematical idea. I wonder if it works for everything. And now I've just challenged that student to think, well, I don't know, now I got to draw some more and see if it actually does work. And can I come up with a mathematical argument? And does it work into my system, right? But I don't have to go down that trail. I might follow up with that student later, like, hey, did you figure out, does that always work? Why does it always work? Okay. So, how is this one different than the first one?
The whole is smaller than the original.
Yeah, I gave you a piece that was larger, right, than the whole. So you had to find the whole here, right? Yeah.
I think the first one we really didn't have to think of a new whole. We kind of already had a whole, we just added on to it. And this one we had to somehow we had to think of two different wholes.
You did have to think of two different wholes, right? Which was, right, multiple ways to interpret a whole, and the whole can be different sizes in this problem. You could even go down the track of something like this. That this is 1/7, right? But what if I said that was 1/9? Is that possible? Can I call that 1/9? Tell me how. What's the whole? Oh, so now this is the whole. So this is 1/9 of this granola bar. So then in relation to this granola bar, what's the size of this one? 7/9. That feels a little bit better. But I want to say that this is 9/7 and this is our whole. But we could do that. You have to think about those wholes and be flexible with that. When we enter fraction calculation with kids, we often give them bare number problems. We don't give them context. We don't work in context with them. They come to know that pictures are babyish and they don't want to draw pictures, but there is a lot of power in defining pictures and being able to be flexible with those pictures and go back and forth with it. Okay? All right, so who wants to suggest an equation? We're not going to call this 1/9. We're still going to call this 1/7. Who wants to suggest an equation that we could write for that? We have 1. 7/7 plus 2/7 is 9/7. What's another equation? Yeah. So that's how we got this one. So 7/7 is the same as 9/7. Take away those 2/7 on the end there. Okay. Anybody have another one that would represent anything on this?
1/7 times 9.
1/7 times 9. And what does that represent? So right here, so the 9/7, I'm going to write it down here because I don't have a very nice board, is 1/7 repeated 9 times. Okay. Anyone else want to write one? Okay. Awesome. All right. Your last one. So you have this bar. It's your granola bar again. I want you to draw a copy of your granola bar. So just below it, so that you always have your original granola bar up top, so you can look back to your original. Okay, so draw a copy. And divide your granola bar into fourths, or make 4 fourths for me. You can do that, right? All right. So, I want you now to draw a new granola bar. You're making a new one again. You love your granola bars. Doesn't matter what flavor it is. You can choose. And your new granola bar needs to be 1/5 longer than the original granola bar. So, who can tell me something you talked about at your tables? What did you talk about? Yeah.
We were saying that for A, the student drew 1/5 of the whole bar, and then for B, they added 1/5 of a part.
So when we went back to the original bar, this was the original bar, right?
Looking at the original bar, yeah.
So where is the original in here?
For A, the first 5 parts would be the original bar.
Okay, so this would be the original.
Mm-hmm. And then they added 1/5 of that part onto the end.
Okay. So 1/5 onto the end. Okay. Anybody else talk about that in your group? Give me a thumb up if that was similar to what your conversation was. Okay. So they took 1/5 of the original bar. So they almost like ignored this one that was, how did this one maybe help this person? Say more about that. It helped you gauge the size.
The size, so we had to make them slightly smaller because we needed 5 parts instead of 4.
So 1/5 is slightly smaller than 1/4. So I could have probably eyeballed it and added 1/5 on being slightly smaller there. But it helped me to gauge the size to add that 1/5 onto the end there. Okay? Who can tell me about this drawing here? There's a lot of mathematical thinking in this drawing. What were they doing?
That's what I did. I'm like, it's 1/5 of 1/4, which is a 20th more.
So this, you're calling this part 1/20th?
Yes.
Hold on. I want you to defend that at your tables. Is that part, I'm agreeing with her, but why? And I want you to talk about it in relation to this picture up here. Why is it 1/20th? So someone at that far table over there, tell me why this is 1/20th.
Because there are 5 pieces in each of those 4.
Okay, so if I actually took my marker and split this up into 5 pieces. Okay?
And then we counted by 5 4 times.
Yes. So this is 5 pieces, 5 parts, and 5 parts, right? So that all together is 20 parts. If I wanted to make the fifth into 20 parts, how many pieces would I have to make in each section? Fourths. What are we doing? Making iterations, but I'm also creating equivalent fractions for fifths and fourths here, right? When I do that. All right. So I made that into 20 parts. So this one piece that she added here, she adds a 20th on. So this one is a fifth of a whole longer. This is what? Yeah, she interpreted it as a fifth of a fourth longer. Okay. Are they both a fifth longer? Yeah. Yeah. We could argue that the directions weren't very clear, right? They're both a fifth longer. We just had to determine which it was. Okay? So, if I wanted to add the right number of 20ths on, how many more would I have to add on to be equivalent to a fifth? You're saying 4? Would I add 4 more? Or would I need 4/5? Or 4/20, excuse me. 4/20. Whoops. Okay. And I would prove that here. Well, I would have to divide these into 4s, right? And then you could line your pieces up there, right? So that can help kids to prove that. Okay. Okay. Yes. I did not have that planned, but I think a student would do that. Yes. Yep. Oh, so I have to monitor myself because for students, I might go, oh, that's really interesting, 1/5 of a 4th, and leave that, and then come back to this discussion because this is a way, and this is also in this orange book, so I knew that I could do this, is taking those pieces and finding what are called co-measures, right? So I have to break this up into 5ths and this into 4ths. It's really interesting. Many resources teach fractions like this with area models. And they do 1/5 of a 4th, right? And so you do this, and you shade your 4th, and then you shade your 5th, right? Up here.
Why do you do that? I don't want to shade that.
And then you go, oh, there it is. There's your 1/20th, right? It doesn't make any sense to kids. It is a model that always works, but what you want to do is, and maybe we'll talk about this in the next session, when you find those co-measures, it's much more. So you guys were actually engaging in the distributive property because you were going 5 parts and 5 parts and 5 parts and 5 parts. So you were taking 1/5 of every 4th, right? You were dividing it up into 5. And so now you know 20 parts. When I work with kids in curriculums like this, they draw these pictures, and I can stop them and say, well, how many parts do you think you're going to draw? I don't know, like 200? I mean, they have no predictive power at all. Because in here, I'm repeating, I'm using iteration again, right? I'm repeating 5 parts, 5 parts, 5. Oh, I'm going to repeat 5 parts 4 times. Eventually, I'm just going to write the 4s in there. I'm not actually going to draw the parts, right? So that I can figure out how many parts are going to be the 20th. And then I can line up my parts. This becomes a counting activity for kids. And when the numbers get big, 1/7 and 1/9, I do not want kids counting 63 boxes. And they will draw it wrong. And they will get the wrong answer. So this is an easy switch in your curriculum materials. And we'll talk, I will plan a session on co-measures and equivalent fractions next time. Because this is such an important model for them to predict why those co-measures work. Yeah.
So last year I had a big chunk of kids who were very high mathematics.
Yeah.
Always thinking
Yeah.
in that way. But then I had those other kids who, if I went down that bunny trail,
Yep.
then I would lose 1/3 of my class.
So that's where.
How do you do both of those?
Yep. So that's where I would then go into some group work, right? So the whole class lesson, my goal is not this, right? My goal, even if someone does the parts like this, I might leave that. I might not choose to put that picture up. I might just choose to put this picture up and defend that picture. But then we go out into our work groups, right? We're going to work on this, and I'm going to pull those students. I'm going to work with those students, and I'm going to say, okay, you guys, I know they're doing that assignment. I want you guys to work on this. And now I'm going to have a small group with them, and I'm going to say, what do you think about this?
You kind of acknowledge the fact that their brain is headed in that direction and don't dwell on it.
Yeah. Okay. Yep. And if we can work with students who are getting the concepts like that, once a week, they'll keep themselves going if you can pose interesting questions to them. So how can you pose some questions to them that are interesting that will keep them going, and then you come back to them once a week and you go, hey, did you guys think about that? Does that work? Did you prove it to me? Because that's going to accelerate them. Not teaching them new content, but asking them questions that's going to force them to think harder. So I want to know, if I added, someone did this picture, what's the name of that piece? They're not going to know the name of that piece. They're going to say it's 1/5 of a 4th. Cool, 1/5 of a 4th, but I want to know what size that piece is. I don't want to know 1/5 of a 4th. I want one fraction name for it. Can you guys figure that out? Go. Now I'm challenging them to go further, but not where everybody's in that space. Because my mathematical goal wasn't that. It was just to think about size, right? You had to think about 1/5 is a little bit smaller than a 4th, and you added it on. So, why iteration? We're going to come back to why iteration. Those are 3 iteration activities. So it's not as boring as just continually lining up parts every time. Iterative fraction scheme is that I view any fraction, it doesn't matter what fraction it is, any fraction as a multiple of the unit. 21/4 is 21 pieces, the size 1/4. When I have this scheme, when I can do these 3 types of problems, I understand a fraction as a number, not as a part out of a whole. I have to consider size, and I have to consider the whole. I am transitioning from a parts out of whole understanding to a measurement understanding. Now the number line is making sense. I can understand what it means to take 4/5 of a piece of rope. I can understand what it means to take 9/7 of a piece of rope. These are measurements that we do in the real world. We do bigger than wholes, right? So I can measure. I can think of that as a number. And the denominator tells me how big that piece is. Tells me the size of it. The numerator tells me how many times to repeat that size. It's a number now. The reason why fractions are so difficult for kids is because they get stuck in shading parts out of wholes. And they are not a number. They are 2 disconnected numbers. A part that I count that's shaded and a part that I count that's not shaded, and they're wholes. You might say, oh no, it's not a whole, it's part of a whole. But they're still counting whole numbers. Their counting sounds like 1, 2, 3, 4 out of 1, 2, 3, 4, 5. They are absolutely disconnecting those pieces. And so it's really important for them to have experiences that force them to think about the denominator as the size relation. And these are the kinds of activities. The activities we did in sessions 1 and 2 are more introductory activities. These would be, as they're getting the idea of iteration, we're going to build on this. We don't start fraction activities with this. This is like you have a lot of experience with 7/7, and you have built 7/7. Now I'm going to say, well, what does it mean to build 9/7, right? So that you really see that. This is the basis, according to Amy Hackenberg and Anderson Norton and Les Steffi, that the iterative fraction scheme is the basis of all fraction calculation. You can see we're going to get equivalent fractions, addition, subtraction, multiplication, division. All calculations come from the understanding of the iterative fraction scheme. And if you don't have an understanding of the iterative fraction scheme, you're memorizing rules that your teacher is telling you to do. And you're probably forgetting them at some point. Because in 6th grade, you're going to learn proportions, and then everything's out the window. Because fractions and proportions, and when do I cross multiply, and when do I do all this other stuff, right? Parts out of wholes is a very limiting mindset for kids of fractions. It is the introductory to fractions. They have to have that introduction. That's how we start it. But we quickly need to move to iteration activities so that they understand the size of the part. So that's the quotes from the book. When any fraction is a multiple of a unit fraction, students can develop virtually all arithmetical operations with fractions based on the conceptual meaning. And I just want to show you where this is in the standards. So this is in 4th grade. In 3rd grade, they do this with materials. But in 4th grade, notice it says, build fractions from unit fractions by applying and extending previous understandings of operations on whole numbers. And I want you to pay special attention to what we call, so that's the cluster heading, that's the topic sentence, right? And the standard says, understand a fraction, A over B, as a sum of fractions 1 over B. Guess what? There's our sum, right? We wrote that just like that. There's our sum. We could have written 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, which you should do in 4th grade. Okay? Decompose a fraction into the sum of fractions with the same denominator in more than one way. Also did that. 5/5 plus 2/5 is 7/5, right? That's what we were working on there. Add and subtract mixed numbers with like denominators. We're getting there a little bit with the 9/7, not quite there, but we are solving word problems about addition and subtraction. We're granola bar manufacturers, man. Here is also 4th grade standards. Apply and extend previous understandings of multiplication to multiply. Notice that the cluster heading is exactly the same. Build understanding of unit fractions. To multiply fraction. Understand a fraction, a over b, as a multiple of 1 over b. 5 repeated copies of 1/4. That's what your standards say we should be talking about. Yet your materials do not build that understanding by giving them static pictures and writing the calculations below them. That's what your materials do. It's in them creating the pieces and you naming those pieces that they're iterating that they're going to get this understanding. So understand a multiple a over b as a multiple of 1 over b. That's exactly what you were doing. And then eventually you'll be able to repeat more than unit fractions. So sharing multiple items. We're going to go on to equal shares, but equally sharing multiple items. But right now I want you to tell your neighbor why iteration is important. Go.
Person to go through the fractions.
$1,000.
That's what I thought. I was like 900.
995.
See, just round it up.
Okay, it's 1,000 minus 5. Okay. So our last experience that we want students to have is to equally share multiple items. So far, we've been equally sharing one item, right? Here's your granola bar. Here's your whatever I gave you. But now we need to talk about multiple items. This is a picture that I took from Ella. Ella is a 6th grade student who I was working with in intervention. And I wrote 6 bars among 4, and this was the picture she drew. Ella had to contextualize it, so we had to share it with our friends, right? These were her friends, Sophia, Mallory, and McKenna. So I want you to take a look at that, and I want you to talk at your tables. What does Ella understand? What's she thinking about? All right. So, what are some things you noticed about Ella's drawing?
She knows how to partition.
Yeah, absolutely. She can partition into 4ths, right? So what does she do? What is she doing with those bars? She's partitioning them, but why?
She's giving each one piece from each bar.
So she's taking 6 bars divided among 4 friends, right? And you're saying that she's taking each of those bars. I'm going to write it like this. Each bar, right? And each bar is going to get divided into 4 parts. So it might look like this. I want you to look at that. Did I count right? 1, 2, 3, 4, 5, 6. Yeah. Is that mathematically correct? What do you think about this? Does this represent Ella's thinking? Talk at your tables about that. Does that represent her thinking? Yeah, so Ella is not thinking this in her brain, right? She is definitely not writing this. I'm trying to write mathematics that matches Ella's thinking, right? So what's her answer? 1 2/4. Where do you see that? Right here, right? How does she get that?
She got 4 forces, that's up to
4 whole bars, because she has 4 friends. And then she has 2 bars left over. 2 bars.
No, she has 4 E's for Ella, which is 4 fourths, and 2 more for 2 fourths.
Everybody gets 6 pieces that are 1/4 in size. So maybe we're thinking about this as pieces that are 1/4 in size. And they're no. So she's saying 6 pieces of 1/4 in size, right? So she's putting those 4ths together. So she puts these together and gets 2 fourths, 3 fourths, 4 fourths. That equals 1 whole, and then she gives.
She thought she had 2 fourths left over, so she just added that.
Then she added that over. So she's really dividing every granola bar, right, into 4ths. And then she's saying each piece, you get one from this granola bar, one from this granola bar, one from this granola bar. She doesn't hand out a whole granola bar. Some kids will do that, right? But she doesn't at all. But she does come up with the one whole right here, right? One whole. Okay. Would you look at Ella's drawing and say, on a continuum of formal notation to informal to no notation, where would you place her? You think in the middle? Why do you think in the middle?
Because like she was saying, I think 2/4 was an add-on. She knew 4/4 was 1.
Yeah, right here, right?
She didn't write that she's adding them. She just counted up.
Okay.
She does have some fractions written, and they are written correctly.
Yeah, so she's actually writing the notation correctly, right? She doesn't write anything about division here, but she's definitely understanding fraction notation, okay? So what do you think about what I did?
She's not showing any addition or anything like that, and that's what you're doing.
Yes. So I'm taking her informalness somewhere over here and trying to push it here, right? So notice I was going here and you guys were like, nope. That's not really what she did. And so now we're going to take 1 divided by 4 and write it as 1/4. Now I'm going to start asking you questions about that, right? Like, is this and this the same? Can I do that? Can I go from here to here? You guys are using the distributive property once again, right? Because you're imagining by interpreting hers is that she's saying every bar is divided into 4th. And now you're distributing that divisor in there. And you're saying 1 divided by 4, 1 divided by 4, 1 divided by 4. In the end, I might not have to do that. I might have to say it's just 6/4 of the bar. That's a little bit down the road for Ella, right? Here's a 5th grade. Oh, so same idea, right? What would Ella want to draw? Talk about that at your tables. What would Ella want to draw? All right. What would Ella want to draw? 17 holes, right? So when Ella gets to this point, am I going to let Ella draw this? No. I'm going to say, what would you draw? Describe it. And let's see if we can write it, right? That's how you move kids away from those pictures. You have enough experience with drawing those pictures accurately. Now tell me in your brain what you would draw. And Ella could say, well, I'd have 17 holes. And then I would do what? Divide it into 32 pieces. And then what would my answer be then? How many of those pieces would I get? I would get 17 pieces that are a 32nd, right? And then I'm going to have her write this. And then, so what do I actually get? 17 30-seconds, right? So pushing kids from these really kind of concrete experiences, has anyone ever heard concrete representational abstract? We tend to interpret that as you kind of build it, and then you draw it, and then you write it. The problem is the drawing and the writing are a huge disconnect for kids. And so you have to give experience where they're kind of building drawing. I would say what Ella did was concrete, even though it was a drawing. She didn't know the answer before she did that, right? She drew the picture, then she counted up. So the representational piece is, tell me what you would do in that drawing. Can you recreate that for yourself? Tell me out loud. Speak it out loud. Name it out loud. And now I'm going to try to represent your thinking with the abstract. And if we don't build that bridge, then all that work we did with the materials, all that work we did with the pictures is lost. Because they either get stuck in one of those two worlds. So what would you draw? What would it look like? Describe it. Say it out loud so that they can conjure up those images. We have to create the habit of mind for them that they visualize it. Create a story for yourself. What would you do? What would that picture look like? Now can you represent that picture mathematically? And that only comes by letting them draw the pictures and connecting the mathematical notation to it. So the standard that we're working on here is a 5th grade standard. This is my favorite, or not so favorite. It's like my favorite no. Interpret a fraction as division of the numerator by the denominator. Solve word problems involving division of whole numbers leading to answers in the form of fractions or mixed numbers. Every curriculum material that I've ever seen is, now you're going to learn that that line means you divide. Bam, we did the standard. You got it. They don't got it. They have no idea what that means. They just can say it back to you. They really don't have this understanding that I'm taking all of those parts and I'm dividing it into force, or I'm dividing it into 30 seconds, and you're going to receive 17 of those parts, right? They're memorizing of is multiplication. They're memorizing all of this stuff, and they can repeat it back to you, but they really don't have a conceptual understanding. They couldn't draw you a picture of it. So this particular standard in the 5th grade is where they gain a lot of experience on equally sharing multiple items. And I will tell you, the books give you word problems. The kids never draw pictures. We just interpret it as division and teach them to write it over 1 and multiply across. Some more, 5th grade. Apply and extend previous understandings to multiply a fraction or a whole number by a fraction. But this is really, again, interpreting the product here as parts of a partition. So reinterpreting that as 6 parts of 1/4. I want you to take a couple of minutes. We've talked about a lot before we do that. And I'm going to go back to this right here, the iterative fraction scheme. 2 things, beyond the whole and sharing multiple items. When I just talk about these experiences, what might you be taking back to your classroom right now? Like how would you give kids these experiences? Why would they be important for the context that you're in? And how would you do that? And not undermine your curriculums, right? You have to move forward. I understand that pressure. Take some time to kind of just process what you thought about today. I want to address a couple things that I think are important coming up. So one of the questions that was talked about is, what about curriculums that do decimals before fractions? Super common in 5th grade. I don't know why, but lots of the current curriculums are teaching decimals before fractions. Here's my problem with that. Students in 4th grade only see decimals as fractions, right? They rewrite tenths and hundredths as fractions. Like, here's a new name. You have a nickname. You can write it like this. Mathematicians do that instead of writing it in fraction form. So it's like this new form for them. And then all of a sudden, you go into 5th grade and you're adding these and you make no reference to fractions. So my suggestion to you is use base 10 materials, right? There's lots of interactive materials. The Math Learning Center is a fantastic site to go on to and find these web-based apps. So even if you don't have them, so the Math Learning Center, and it's usually the first one coming up, free math apps. It's under their resources tab are the math apps, and it will take you to this page, and there's all kinds of different ones. There's fractions, there's number frames, which, by the way, this is a fantastic way, because I got really lucky today that I drew the pieces accurate. I usually don't. To do, hey, here's your granola bar. Can you make it into fourths? And then this is on your board. And now you at least have the fourths that are the right size. And you can then make the fifths, So, and then you can copy and you can draw on it. You can shade things that you want to. It's a fantastic site. I use this all the time in intervention with kids, especially older kids. And they can draw with their fingers. If you have iPads, they can draw right on the iPad with it. It's awesome. So this is a great site for fractions. Notice they don't have area models on here. Oh, so I got distracted. Hold on. That's the second thing I wanted to talk about. So the other one that they have, and I didn't know this until I kind of looked it up. So if I go back to math apps, number pieces, there's basic and then there's these number pieces. It doesn't matter, I don't think. If you're doing fractional or if you're doing decimals, to have those base 10 blocks out there for them. So here's your tenths, right? And you just put them right out there, right? And now I can, line the little pieces up right next to them and talk about those tenths and hundredths, and they can see the hundredths embedded inside of the tenths. Otherwise, it just becomes a lot of nonsense, and then you introduce things that are just, memorizing things like you line up the decimals, you drop them down, you fill in the things, and all the rules get mixed up for the kids. So I really encourage you to use these as pictures. So I want to talk a little bit, because I dropped the bomb about the area model. And a lot of people swear by the area model for fraction multiplication. I do know that. I just don't think it promotes the reasoning that we want them to promote in the beginning. So once kids get to the place where you're saying, this is my granola bar, you get a fourth of it. But now you have to share that fourth with 5 other people. So you get a fifth of the fourth. Can you draw what that would look like? Right? They're going to draw the 20th inside of there. And then how do you know it's a 20th? Because that's 5, that's 5, that's 5, and that's 5. I don't even have to draw those pieces. In the beginning I might, but eventually I'll just start writing 5, 5, 5 in there. We can then, once they get really good at that and they're thinking about the predictive power of a fifth of a fourth or any kind of unit fraction of a unit fraction, we can then introduce the area model and say, okay, so today I don't have bubble tape. I have a pan of brownies. Nobody's going to slice brownies like this, right? So that's where the area model could come in and you could interpret it. I just wouldn't do it in the beginning because when they draw the lines, they draw fourths, then they draw fifths, and they're not connected at all. In this picture, the fourths and the fifths are connected because the fifths are inside of the fourths. That's where the distributing comes. Right, is that idea is, I have to make fifths in here, I have to make fifths in here, I have to make fifths in here. And it really connects to the language, a fifth of a fourth. What does that mean? When they draw those pictures, they're not really understanding that they're taking fourths and splitting those fourths up into fifths.
That makes so much more sense than the area model. Like they have to do that overlapping because they will do it because I taught them how to do it.
Yep.
But even for me teaching it, I have a hard time explaining why they need to learn it that way.
Yes.
And so they just put up with learning how to do it, but they don't really internalize what is going on. And doing it that way is just so much easier.
So one point that was brought up is the MSEP will show them an area model that they have to interpret, which is why start with the linear models. Like I know we're playing the test game, but this is real. I do think an area model is powerful. So divide brownies, but after they have the understanding of what that means. And then what you do is you have the brownie pans divided up into fourths, and you say, I need to split these, though, into fifths. So I need to take fifths of fourths. How am I going to do that? If you suggest the long, skinny ones, you might say, who cuts their brownies like that? Do you actually hand out pieces of brownies like that at your party? That's weird. What's another way we could cut these brownies? And now we're cutting in different directions. But I don't do that until I really know that they can distribute those parts because I want them to predict. Inside my fourth, I'm going to make 5 pieces. Inside this fourth, I'm going to make 5 brownies. Inside this fourth, I'm going to make 5 brownies. And they don't learn that initially from the area model. Eventually, they can translate that.
But you can do the same thing in the area model if you just don't draw the line all the way across your array.
Yeah.
If you only draw it in that first fourth, that you're dividing it into 5 pieces, then they can still see this is 5, and then this would have 5, this would have 5, this would have 5. It's when you draw it all the way across that they now have no idea why you're drawing it all the way across.
Yep. So, yes. What my experience has been with that when I've worked with struggling students, not students who are translating between them, is then they're not really thinking about the distributing, and so then they make 5 pieces here, and then they make 5 pieces here, and then they make 5 pieces here, and they make 5 pieces here, and then they go back and they recount everything. And so, at least in my experience working in intervention, this has helped them move faster than that, and then I eventually would introduce that. So, but try it out. See if you can get kids. But I've had lots of kids who are 2 or 3 grade levels behind that we've worked with in intervention, and they want to count. So, yeah. So, try it out, right? But that's one place you can invent in your curriculums. Hey, I'm going to change the model here. But also be aware of the testing. So, unfortunately, that's a place we have to live. Okay, so if you have a piece of paper at your table, the next session, I'm really interested to hear about the struggles that you're having with your curriculums. We've talked about a couple of them today, but if you could name like 2 or 3 of your biggest struggles that you feel like, I do this, and the students are not connecting with it, but I'm doing it because that's what's there, that might help me to kind of figure out what to do next with the curriculum packages. So I can help you make those better. And then once you do that, oops. They want you to work on your implementation guide and what you're taking back. Is everyone working on those? Okay. So for the last 14 minutes, I think this is the survey, the bit.ly, and I'll put that back up. But if you could go in to your Google Classroom, they want you to review your commitment. And yeah, I'm doing it. I'm following the directions. State your intention. So your intention could change. From today's learning, what's your intention? What are you going to try? What are you going to be curious about? What are you going to, gather information about? And I'm going to challenge you in the next session to bring back pictures. And you can send them, just upload them into the Google Classroom. I think you can put them right in your implementation document, and I'll look through them. Send those pictures so we can look at pictures of students' fraction work and we can dissect it and say, what were they thinking? What were they doing? What would we do next? What is their misconception? Looking at student work is really great. Or bring the actual papers and we can look at them. So bring something back that represents student work in fraction so we can kind of think about where are they getting stuck.